Hi everyone, today we're going to talk about modeling using variation. So we've got a couple of different types of variation that we're going to talk about. First one I want to talk about is direct variation. Okay, so when you're thinking about it, you've got, and the general form of the equation is, let me get my pen here, it's just this y equals kx. So k is some constant value. It doesn't matter what it is. So let's say y is equal to 2x. So as x increases, y increases by 2, but that's your scale factor, okay? So direct variation is very straightforward. K is called your constant of variation. And so let me show you how we use this in a problem. Constant of variation. Okay, let's go through let's go through an example here. So the weight of a great white shark varies directly, and they're going to tell you right in the problem what kind of variation it is. So they're telling you right here, it says varies directly as the cube of its length. Okay, so very similar to what we just did. It says the weight of a great white shark. So the weight of a great white shark varies directly as the cube of its length. So the cube of its length, we still have that constant of variation that we need to figure out. Okay, so a great white shark caught off Catalina Island, California was 15 feet long and weighed 2,025 pounds. Okay, so we know the weight and we know the length, so we can find that constant of variation, and then we can use that, because that number should not change, to find now the weight of the shark that was in the novel Jaws, which is the same shark that was also in the movie. But anyway, okay, so let's go through this then. It says that a 15 feet long, or a shark caught was 15 feet long and weighed 2,025 pounds. So I have 2,025 is equal to k, because that's what I'm trying to find, times 15 cubed. I'll pull up my calculator here. And then it's really just a straight calculation. Let's see. We have 2,025 divided by 15 cubed. And so our constant of variation then is 0.6. Okay, so now it says what was the weight of a 25-foot long shark? Well, okay, so now we have weight. We have our k value here. We know is now 0.6. Excuse me. And we know that our shark is 25 feet long. So we're doing 0.6 times 25 cubed. So 0.6 times 25 cubed gives me 9,375 pounds. That is one big shark. Okay, but that's the idea behind direct variation. This might just be L. It might be L squared, it might be L cubed, it might be L to the 5th. Whatever the problem says is what you're going to put in there. But remember that constant of variation is what you're looking for. Once you have that, then you can go and solve the rest of the problem. So the letters that they use is going to depend on the problem and what power. There might not be an exponent. It might be very straightforward like this. It might be y is equal to kx squared. It might be y is equal to kx cubed. Whatever it is, all of those represent direct variation. Okay, inverse variation is a little bit different, and I like to think of it like this. And I'm going to write it this way first so you kind of get an idea of what's going on here. If I have x times y is equal to some constant k. So let's say, for example, x times y is equal to 8. And if I were to go ahead and put in a table of values, right, when x is 1, y is 8. When x is 2, y is 4 when x is 4, y is 2 when x is 8, y is 1. And so inverse variation, you see your two variables are doing two different things, right? Because we're multiplying them together in this particular example, and it's the product of a constant. As one of the numbers increases, the other one has to decrease. Okay, it has to. That's the idea behind inverse variation. As one gets larger, the other one gets smaller. Here's the thing that we don't normally write it like this. We normally write it in terms of y. So in this case, it would be y is equal to k over x. But that's the idea. As one is getting larger, the other one has to get smaller. That's just the idea behind it. But I think sometimes it's easier to visualize it like this. Okay, so a little bit different. Remember, direct variation was y is equal to k times x. Inverse variation is y is equal to k over x. So let's do an example of that. The length of a violin string varies inversely. So again, they're going to tell you exactly what kind of variation you're doing right in the problem as the frequency of its vibrations. Okay, so the length of a violin string varies inversely as the frequency of its vibrations. Okay, remember k is our constant of variation. So a violin string 8 inches long vibrates at a frequency of 640 cycles per second. Okay, so we can figure out what k is, right? If we just cross multiply, we're just going to do 8 times 640. And that gives us 5120. So that's our constant of variation. Okay, so now we can sort of, you know, make an assumption or make a guess about what's actually going to happen here, right? So what is the frequency of a 10-inch string? So if the string is getting longer, what do you think is going to happen to your frequency, right? You should know this, but let's do it out. So L is equal to k over f, right? Our new L is 10. Our k value is 5120, and we're trying to find f. So if we cross multiply, we get 10f is 5120. So f is just going to be 512 cycles per second. Makes sense, right? Our length went up, so our frequency went down. Okay, so they're both very straightforward. It's just a matter of making sure that you set it up correctly. Just a real quick explanation of joint variation. It's when you're talking about the product of two things. So instead of maybe having y is equal to kx as you would in direct variation, in joint variation you would have y is equal to k times xz, right, times the product of two things. Okay, that would be joint variation. In inverse form, so if your y is equal to k over x, then you might have y is equal to k over the product of two things. So it might be, and I can't think of one off the top of my head, but joint variation might be, I don't know, the length of a rectangular prism varies directly as the product of its depth and width, or something along those lines. That's how it would be worded. Okay. Combined variation is when you're just combining direct and inverse into the same problem. So you would say, well, y might vary directly as x, but inversely as z. Okay, so that's the idea behind those. The problem, you approach the problem the exact same way. Every single one of these problems, you're finding that constant of variation first, and then you're plugging it back in with the new data that you have to find that missing piece. So it is pretty straightforward. We are going to review this more tomorrow in class, just to let you guys know. And then tomorrow there'll just be a graded assignment, which is just more of this kind of stuff. Okay, so hopefully this helped. Have a great day. I'll see you all tomorrow in class. Bye, everybody.